The floor function is the opposite of the ceiling function, but it works in a similar way. The floor function returns the largest value below the argument you sent to it. Standing on the floor of your house, the floor is below your hand in general, but you can bend over and touch the floor, but you can't touch lower than the floor. Here's how it works in C. First send floor D1, and it returns 1, which is the largest whole number below 1.35. Repeat by sending it D3, and you get 17. Again, that's the largest whole value below 17.005. So now let's try a negative. Use D4 as the argument, and you get -3. Again, a number line proves that -3 is the largest whole number below -2.6. Finally, as with the ceiling function, if you call the floor function with a whole number, like 6, then it simply returns the same whole number. Weird thing, the C language doesn't have an exponent operator. It's got add, subtract, multiply, divide, modulus, but no exponent operator. Instead, programmers use the POW function. Think of taking the number 2 and raising it to the third power. In math, we'd say that 2 is the base and 3 is the exponent. We get 8 as a result of raising 2 to the third power. The POW function lets us do the same thing. This function has 2 arguments, a base and an exponent in that order. So let's send it 2 for the base and 3 as the exponent. Notice the function returns the value 8. Now let's use variables for the function call. Here D1 will be the base and N2 the exponent. And we get a return value of 3.321506, because that's the approximation to 6 decimal places anyway, of 1.35 raised to the 4th power. Notice that if the exponent is 0, the result is 1, because any value raised to the 0 power is 1. Speaking of raising a base to a power, our last math function is a logarithm function. And who doesn't love logarithms? The log 10 function returns the base 10 log of its argument. Let's try it with 100. Notice we get a result of 2 because 10 raised to the power 2 gives us 100. Now let's use an argument of 45. Here the result is 1.653213. Let's use another function to check how close our result is. So if I raise 10 to the 1.653213 power, I should get close to 45, right? The output is showing that 10 raised to the 1.653213 power is 45. As I said earlier, the math.h library has many other math functions, but these will work for the programs we're going to write in our course. The best way to really learn these is to practice. So I'm going to sign off and let you do exactly that. Thank you all for watching.